Chapters 11 and 12, Estimation of Absolute and Relative Performance, Part 3. So in this part, we'll start Chapter 12. So Chapter 12 will be covered in two parts, and this is the first part of Chapter 12. So in Chapter 12, we're going to compare two or more systems' performance. So we'll consider the independent sampling technique and common random number CRN or correlated sampling technique, and also confidence intervals with specified precision. Okay, let's at first have the approach, the general approach that we are going to follow in this chapter in order to compare two or more systems. So here we assume that we have two systems, so two simulation systems, and theta 1 is the performance measure for system 1, and theta 2 is the performance measure for system 2. And here we do have the data about the replications. So we have two systems here are replications, let's say, and here we have the data set. So we can calculate the sample mean and sample variance for each system independently by the equations that we do have here. Okay. So now we are going to make a confidence interval on the difference in mean performance. Okay, so we'll build a confidence interval for theta 1 minus theta 2. Okay, so now if the confidence interval is totally lies on the left of the zero, this case, so here there is strong evidence for hypothesis theta 1 less than theta 2. Okay, or if the CI is totally lies on the right side of the zero, this case as you see here. Okay, so here there's a strong evidence that for the hypothesis of theta 1 greater than theta 2, and if the CI contains 0, so 0 lies inside the interval of the CI, then we can say there is a strong evidence for the hypothesis that theta 1 equals theta 2. Okay, so and the CI, the confidence interval for theta 1 minus theta 2 will be obtained by this equation: y bar 1 minus y bar 2 plus minus 3 half alpha and nu as the degrees of freedom times a standard error of y bar 1 minus y bar 2. So we'll see how we can calculate a standard error of the difference and also the degrees of freedom. Okay. So for the independent sampling, when we say that we have independent sampling, we mean that the stream of random numbers used in the two models are totally different and independent. Therefore, the two simulation model will be independent as well. Okay, so because of that, the output of the system for the output of the system 1 and system 2 will be also statistically independent. Okay, so the variance of sample mean for y bar I will be this. Okay, sigma squared divided by Ri. So here we assume that we do have two systems. So the variance of y bar 1 minus y bar 2 will be the summation of the variances. So it will be this equation. Okay. And now we are going to make a confidence interval in the case of independent sampling. Okay, so the point estimator here is y bar 1 minus y bar 2, right? And the sample variance for system I will be obtained by this equation that we do have here. And so the standard error will be this, right? We obtain the variance of the difference in means by s square 1 divided by r1 plus s square 2 divided by r2. Now the standard error will be the square root of this equation. Okay, so now we do have the standard error of y bar 1 minus y bar 2, and we just need to obtain the degrees of freedom in order to obtain the t half alpha and nu. Okay, so the degrees of freedom for the case of independent sampling, nu here will be obtained by this equation. So yeah, so from now on, it's so easy. So we just calculate the degrees of freedom, the standard error of y bar 1 minus y bar 2, and also the point estimators y bar 1 and y bar 2. And then by having these values and obtaining the t half alpha and nu, we can construct a confidence interval for theta 1 minus theta 2 with 1 minus alpha percent confidence level. Okay. So here we have an example. The average waiting time in minutes of customers in an MM1 queue and MM2 queue are estimated from 15 replications. So we want to develop a 95% confidence interval based on the data that we have here for 15 replications for the two system settings. So the solution of this example is in Excel, and I will upload that Excel file in Learn, so you will find the solution over there. So it's so easy. We just implement those equations that we obtained in the previous slides in Excel, and we'll calculate the confidence interval. Okay.